Hello students, in this video we are going to see the chemistry part solution. That means 50 questions from 51 to 100 for FT03. Recently the unit of AMU, atomic mass unit, is replaced by U, that is unified mass, which is equal to 1.66 into 10 to the power minus 27 kilogram. The value will not change, but AMU now we are going to use as U. It is decided by IUPAC. According to Avogadro's law, we know that Avogadro's law, if you increase the number of moles, the volume is also going to increase. Simply, actually, 1 mole, that means 22.4 liter. If you will increase the number of moles, that means 2 mole, so 44.8 liter. Simple. So, if you will increase the number of moles, volume will also increase. This is Avogadro's law. The ratio of minimum wavelength of Lyman and Balmer series. So first of all, we should see the minimum wavelength. Minimum wavelength. That means highest energy, right? Highest energy. Minimum wavelength बोले तो highest energy. Question number 53. Lyman and Balmer. We know that N1 is fixed for Lyman, N1 is fixed for Balmer. Lyman, Balmer, it is 2, है ना? But minimum wavelength, that means highest energy. Highest energy, it will be possible only when the electron is coming from the last cell, है ना? N2 is equal to infinity. So here 1 upon lambda is equal to Rz square, 1 upon N1 square minus 1 upon N2 square. R, it is 1 N1 square. That means 1 minus 1 upon infinity square R into 1. Because 1 upon infinity square, that it will become 0. So, 1 minus 0, that means R. 1 upon it will be R, okay. Here, if you see, it is equal to infinity. 1 upon lambda is equal to Rz square. 1 upon N1 square minus 1 upon N2 square. 2 to the square minus infinity square. So it will be R upon 4 because 2 square 4 and it will be 0 na. So 1 upon lambda is equal to R upon 4. What is the question? The question is that the ratio of minimum wavelength. He is asking the minimum wavelength, ratio of wavelength. So it is 1 upon lambda. So lambda L, Lyman, it is 1 upon R. Lambda Balmer, it is R upon 4 upon R. Okay. So first Lyman, then Balmer ratio. That means he is interested in lambda L and lambda Balmer. 1 upon R, 4 upon R. 1 upon R, R upon 4. 1 upon 4 बोले तो 0.25. 0.25 will be the right answer. That is question number 53. We have seen the solution. Now, if the shortest wavelength of Lyman series of hydrogen atom is X, he is saying that shortest wavelength, that means highest energy for hydrogen atom, then wavelength of first line of Balmer series for hydrogen atom. Let's see the question. Lyman series shortest wavelength, that means highest energy. We have seen that Lyman series shortest wavelength, that means highest energy, it was 1 upon lambda is equal to R. That means he is talking about that in the first case, he is talking about 1 upon lambda is equal to R. His means to say he is providing you 1 upon lambda is equal to R. And he is saying that the shortest wavelength of Lyman series of a hydrogen atom, it is X. That means he is providing the value of lambda. So it is X. So 1 upon X is equal to R. That means he want to say that the value of Rydberg constant is 1 upon X. How I have solved it? 1 upon lambda is equal to rz square 1 minus 1 upon n1 square minus 1 upon n2 square. N1 you will put 1, n2 is you will put infinity. So you will get this. You will get 1 upon lambda is equal to r. Because I have solved it here, so I am not going to solve it again. Now the rest of the question is that wavelength of first line of Balmer series. Balmer series, that means n1 is equal to 2 and n2 is equal to 3 because it is the first line. Now 1 upon lambda is equal to rz square 1 upon n1 square minus 1 upon n2 square 1 upon lambda r z square बोले तो 1 2 square 3 square 1 upon lambda. In place of r, I am going to put 1 upon x. 1 square, that means 1. 1 upon 4 minus 1 upon 9. Okay. 36. 9 minus 4. It is 5 upon 36x. It is 1 upon lambda. So lambda will be equal to 36x upon 5. है ना? 36x upon 5. So B will be the right answer here. Yeah, that is the question number 54 and B. Yes, right. Now move forward. In an atom having two, that means first cell is having 2 electrons, second is 8, 8, 2 electrons. The number of electrons with m is equal to 0 and s is equal to plus half. First of all, 2 plus 8, 10, 10 plus 8, 18, 18 plus 2, 20. That means he's talking about 20 atomic number, that means calcium. So listen, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. He's talking about calcium. Now m is equal to 0. Yes, for this m is equal to 0, m is equal to 0. And now and s is equal to, listen, now for this m is equal to 0, m is equal to 0, minus 1, 0 plus 1, 0 minus 1, 0 plus 1, 0. So you can see that how many orbitals are having m is equal to 0. Now s should be plus half, that means clockwise only. So this can have only one electron, that is clockwise. This can also have one electron, that will be clockwise, that will be clockwise, that will be clockwise. है ना? And yes, it is also having only, yes, we know that an orbital can have 2 electrons, but the second electron will be having the spin quantum number equal to minus half, not plus half. So that's why it will not be right. So here 1, 2, 3, 4, 5, 6. Answer will be 6. Good question. Now question number 56. The best reason to account for the general tendency of atomic diameters to decrease as the atomic number increases within a period of the periodic table is the fact. The best reason to account for the general tendency of atomic radius to decrease as the atomic number increases within a period. In a period, as you will move from left to right, size decreases because cell same, but the Z effective is going to increase because the number of proton in the nucleus is going to increase. Outer electrons repel, no. Closer packing, no. The number of neutrons increases, yes, neutrons increases, but there is no any matter. The increasing nuclear attraction force, yes, nuclear Z effect is going to increase. Maximum size of the first member of a period is due to maximum size. We know that first element is having, all the element in a period are having same cell, but the first element is having least number of proton. As you will increase the atomic number of protons in the nucleus is going to increase. So first atom in the period will be having least number of proton, that means least number of least value of Z effective, that means highest size. So maximum size of first member of a period is due to minimum Z effective, है ना? Cell will be same. How is it? First element will be having maximum number of cell, and all the elements in the in a given period are having the same number of cell. Second period will be having the second cell. All the elements will be having second cell. You know? Which of the following is paramagnetic in nature? So if you will be having any such type of question, so first, if any molecule is having odd number of electron, it will be definitely paramagnetic. Let's see, is there any element, any molecule or species having odd number of electron? O2 minus. O2 is having 16 electrons, 16 plus 1, 17. It will be paramagnetic. 14, 14 and 14. I do not know they are paramagnetic or diamagnetic. We will have to apply if the electrons are even in number. So we will have to fill the electrons and then we will be able to predict. But we have found the answer now with this trick, that if the number of electrons are odd in number, so that means it will be definitely paramagnetic in nature. Do not have bond order. 2.5. There is a formula for bond order. If the electrons are more than 14, so 20 minus number of electron upon 2. So O2 minus, it is having 17 electron. It is having 17. So 20 minus 17 upon 2, that is 3 upon 2, that means 1.5. So it is the molecule which is not having 2.5 bond order. Let's see for this. 20 minus number of electron, that is 15 upon 2, 5 upon 2, that is 2.5. And 2 plus, it is having less electron than 14. So the formula for that, 14 minus number of electrons, number of electron minus 8 upon 2. This is the formula for calculating bond order of species that are having electrons equal to 14 or less than 14. So it is having 7 to the 14, 14 minus 13 electron. So 13 minus 8 upon 2, that means 5 upon 2, that means 2.5. It is having N2 minus 14 plus 15. So 15, we have seen that if there is any having 15 electrons, so 2.5, 2.5, 2.5, 2.5, it will be the species that will not be having 2.5 bond order. So A option. Question number 60. The electron adds to which one of the following orbitals during change of N2 to N2 minus? If you will see the energy orbital for electrons having more than 14 electron, so you will see sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, pi, sigma 2p z, pi 2p x, pi 2p y, pi star 2p x, pi star 2p y. So 8 electron has been filled, 9th, 10th, 11th, 12th, 13, 14 and then 15. So pi star orbital. Electron is going to enter in pi star orbital, antibonding pi orbital. Now, question number 61. In which of the following reaction H2O2 acts as a reducing agent? If the H2O2 is acting as a reducing agent, that means its oxidation state is going to be increased. So I will have to see that in which case the oxidation state of O in H2O2 is going to increase, oxidize. Now it will be oxidized, and it's oxidized, that means its oxidation state will be increased. So H2O2, in H2O2 it is having -1 oxidation state. Here it is having -2. It is a decrease. No, it is -1 and it is 0. From -1 to 0, that means it is an increasement. That means H2O2 is being oxidized and it will reduce other, that means acting as a reducing agent. है ना? Here you will see that again it is having -1, -2. Reduction of H2O2 is taking place. -1 to -2 reduction is already taking place, right? In this case also. Question number 62. We will see in the balanced equation. I am going to solve the question here. Here I will solve this question. Mn, it is having +7 here. It is having +2, है ना? +2. So the reduction step is MnO4 minus gives Mn plus. It is the reduction process, and oxidation, if I am talking about that, C2O4 2 minus gives CO2. It is the oxidation, right? Now it is there is a carbon atom whose oxidation state is going to be changed. If you will see, there is +4 and I think there is a +3, right? So oxidation +7 to +2 reduction, right? Now I'm going to balance the number that atom whose oxidation state is going to be changed. In the first half reaction, you can see that Mn is the element whose oxidation state is going to be changed, and Mn is 1 on the left hand side, Mn is 1 on the right hand side. Here C is not same on both of the side. There are two C, there is only one C. So I will have to equate the atom whose oxidation state is going to be changed. Now I will see that 2 carbon, 4 oxygen, 4 oxygen, so balanced. But it is not having the charge same on both of the side. There is -2 charge, there is 0 charge. So I will have to add 2 electron here. Now in this case, in the first, MnO4 minus gives Mn2 plus. Here there is 4 oxygen on the left hand side, there is no oxygen on the right hand side, so 4H2O I will add to equate the number of oxygen atom. Now 8 hydrogen are present on the right hand side, but there is no even a single hydrogen on the left hand side, so I will add 8H plus on the left hand side. So I will see that the hydrogen atom 8, Mn1, 1, oxygen 4, 4, but the charge is it same or not? 8 plus -1, so there is +7 charge, there is +2 charge, so I will have to add 5 electron here, so that on the first reaction also there will be equal charge, that is +2 charge on the left hand side, +2 charge on the right hand side. Now I will equate the number of electron. I will multiply 5 electrons by 2, 10 electrons. I will multiply by 5 to the 10 electrons. Now listen, 2 8 is a 16H plus, 2 MnO4 minus, and 5 C2O4 minus, and 2 Mn plus 8 H2O plus 10 CO2. So how many molecules of CO2 are going to be formed? 10, 62. You can see 10 moles of CO2 are going to be formed in the balanced equation, right? Now question number 63. Which of the following configurations of 3D series exhibits the largest number of oxidation state? You know, this is the element. By the way, you can see that it is a factual question, but I'm telling the reason also that why this element, that is manganese, is the right answer here. It can have 2 electrons can be removed, and if the 5 electrons will also be removed, so it can show +7 oxygen state. It is manganese, right? That will be the right answer for 63rd question. 63 question here, that is C, right? So it can show +7 oxidation state also. In the 3D series, there is no even a single element which can show this high number of oxygen state +7. No. So +2, +3, +4, +5, +7, right? This type of it can show, and this number is going to be increased to +7 till, right? Till +7. So question number next question is 64. What is the incorrect for? So we have seen that it is having +2 oxygen state and 3D 6 configuration. 1 2 3 4, है ना? So +2 oxygen state is right, and it exhibits diamagnetic character. We know that if there is a strong field ligand CN, so they will be paired, है ना, and hybridized. So D2sp3 there will be hybridization. So it is a diamagnetic. It is also right, है ना? It exhibits paramagnetic. No, so C will be the right answer because A and B right. So he is asking the incorrect. A and B are correct here. It was D2sp3. Yes, it is involved in D2sp3. A planar complex MABCD gives. So we know that a planar. So there is a plane of symmetry. So it cannot show optical isomerism, but it can provide you geometrical isomers like MA. So in front of A, in the transposition just opposite to A, there can be B, C, D. In place of B to the A, so there can be a C. In the next, there can be a D. So in this way, we will be having 3 geometrical isomers. So it can show 3 geometrical isomers. A opposite to B, A opposite to C, A is opposite to D. Compounds which contain direct metal carbon bonds are called organometallic compounds. Organic because carbon metal के बीच में bond, so there is a bond between organometallic, so organometallic compound. Silicones, my dear students, it is belonging to 14th group carbon family and R2SiO. It is a factual question, no one can do anything. R2SiO, C option will be the right answer. There is a very less chance that any question, you know, higher number of question is going to be raised from P block. 1 or 2 question may be raised. So that's why in all these paper FT 1 to 5 you will see there will be only one question related to P block. The difference between heats of reaction at constant pressure and constant volume for this. My dear students, he is interested in Cp minus Cv, which is equal to N into R. So we know that it is 12 gaseous moles on the right hand side and 15 gaseous mole on the left hand side. So 12 minus 15, that means 3. So 3 into, if you see question number 68, so 3 into it is 12 minus 15, so minus n number of moles is minus n into R. So it is R gas constant, that is 2 calorie, or you can put that value. So what is going to be happen, 3 to the 6 approximately, it will be in minus, so it will be minus 7.43, or you can see that he is interested in the difference between heats of reaction at constant pressure and constant volume for the reaction. So 12 minus 15, you will do 3 stage approximately, it will be like this. Question number, that is question number 68. Okay, now for the reaction, this is the reaction, it is given to you, H2 plus Cl2. Okay, what he is asking, H2 plus Cl2 is Y. Which of the following statement is correct statement? Listen, the statement which is given there, H2Cl2 here liquid and H2Cl2 here gas. Okay, let's see. In the first statement, it is given as H2 plus Cl2 gives 2HCl gas plus X. Left hand side energy, right hand side energy, same. Law of conservation of energy. So I'm going to take 25 plus 25, 50 unit energy on the left hand side. So obviously 25, 25, 50 unit energy on the right hand side. Left hand side in both of the equation, because left hand side of both of the equation is same, but right hand side, you know, what is the energy or what is the energy of 2HCl liquid or 2HCl gas I'm going to take. HCl is present in both the cases, but in the first case it is present in the gaseous state. So suppose I am going to take 40 unit energy for gaseous state. So for liquid state I am going to take roughly 30 unit energy. I will have to take less energy than this, because in gaseous state molecules will be having more energy because they are having movement continuously, random motion. So there will be higher energy in gaseous state. So what is the value of X here? So what I will take, it is 50 on the left hand side, so 40 plus 10 I will take. So X is equal to 10. It is 30, so I will take 20 on the right hand side. So X is 10 or Y is equal to 20. So Y is greater than X. Y is greater than X. You can assume the answer in this way, right? You will take HCl gas, HCl liquid. HCl gas will be having higher energy as compared to HCl liquid. Now question number next, that is it's not working, 70, right? PCl5 reversible PCl3 plus Cl2. In the above reaction, the equilibrium condition, mole fraction of PCl5 is 0.4, okay, 0.4, and mole fraction of Cl2 it is 0.3, okay. The mole fraction of PCl3, online students, in equilibrium the reactants and products all are present. There are 3 species at equilibrium, PCl5, PCl3 and Cl2, and we know that the mole fraction of all the components or all the species, sum of the mole fraction of all the species is always equal to 1. So 0.4 plus mole fraction of this plus 0.3, it will be equal to 1. So 0.4 plus 0.3, 0.7 plus x is equal to 1. So x will be equal to 1 minus 0.7, that means 0.3. It will be the right answer for this question. Now next question number 71. You will see that he is providing the condition, Le-Chatelier principle will be followed here. High pressure, if this reaction is taking place favorable, the condition high pressure is favorable for this, and low temperature. Low temperature, why? Because it is exothermic, so obviously low temperature will be there. Favorable condition, then which is right option? A is the number of moles of reactant, B plus C is the number of moles of product. Listen here, if high pressure is favorable, that means at high pressure this reaction will proceed in the forward direction. That means now, and we know that at high pressure the reaction will be proceeding in that direction where the volume is low. That means number of gaseous moles low, and where that means it is in the forward direction the volume is low. That means B plus C is less than A. B plus C is less than A. Barabar na? Now the pH of H2O at its boiling point. We know that boiling point, that means obviously we are going to increase the temperature, and on increasing the temperature ionization increases. On increasing the temperature ionization increases. Listen, if I am going to say 25 degrees Celsius, the ionization of H2O, that means 2H plus and OH minus, it is 10 to power minus 7 mole per liter. है ना? That means if I am going to take 1 mole, so 10 to power minus 7 mole out of that 1 mole is going to be ionized, or in another way, if I am going to take 10 to power 7 molecule of H2O, 1 molecule will be ionized in the form of H plus and OH minus ion. If I am going to increase and if I will calculate pH, so it will be 7, negative logarithmic of this minus log H plus. And if I am going to increase the temperature, as we know, on increasing the temperature ionization will increase. Suppose I am increasing the temperature and ionization also will increase. So increase, that means 10 to power minus 7. Suppose it is going to be increased to 10 to power minus 6. Yes, 10 to power minus 6 is a greater number as compared to 10 to power minus 7. We know higher the power in negative, lesser will be the value. Lesser will be the power in negative, higher will be the value. So suppose at high temperature, what it means, at high temperature ionization is going to be increased. If now I am going to take negative logarithmic of this to find the pH value, it will be 6. So that means less than 7, right? I am going to assume that the ionization is going to increase to 10 to power minus 6 on increase the temperature. So it will be less than 7, less than 7, right? So question number 73, we will see in this question what is given to us. What is given to us here? Hanji. So solubility of AgBr will be minimum. So AgBr is going to be ionized into Ag plus and Br minus ion. Listen, pure water is not providing Ag plus or Br minus ion, so there will be no effect. AgNO3 will provide you Ag plus, NaBr will provide you Br minus, CaBr2 will provide you 2Br. Listen, it will provide you 1Br, okay, you know, it will be affected, it will proceed in the backward direction because it is providing same ion Br minus. It is providing Ag plus same ion, so it will be proceeding in the backward direction, but it is providing you 2Br, so it will be having a great effect, more effect than C and D. So B will be, because it is providing you 2Br ion, so it will proceed in the backward direction, it will shift in the backward direction to a greater extent. Now question number 74, which of the following statement is correct? Oxidation occurs at anode in both galvanic and electrolytic. Yes, oxidation will be always taking place at oxidation will be taking place at anode and reduction will be taking place at cathode, always, whatever the type of cell, doesn't matter. 74. E node is equal to given to you, E node is given to you, the EMF of the voltaic cell. Listen, here oxidation Ni to Ni node N2 plus, you know, it is reduction given to us while Ni is going to be oxidized. So 0.25 Au3 plus to Au, yes, it is given 1.50, na? Or Ni to Ni2 plus, and they are providing, so I will have to change the sign, and Au3 plus to Au, so 1 point, so it is 1.75. It is E node that I have found, E node, है ना, E node I have found. Now I will see 1.7. E is equal to E node minus 0.06 upon N, log concentration of product is Ni2 plus, reactant is Au3 plus, है ना, Ni2 plus and reactant is Au3 plus. And if you will balance it, so what you will have to do now, you will have to multiply this equation by 3 because 2 electrons are being involved here, 3 electrons are being involved here, so you will multiply it by 2, so 2 Au3 plus and 3 Ni, so Ni cube Au2, 1.75 minus 0.06 upon N, number of electrons, 6 electron will be involved here. Concentration of Ni2 plus, it is 1, concentration of Au3 plus, it is 1, 1 cube will be 1, 1 square will be 1, so log 1, it is log 1, log 1 is 0, so it will be 0, so E will be equal to 1.75 here, 1.75, it will be the right answer for this question. 75th question we have solved it, it will be having the answer C. Now a current of 9.65 flowing for 10 minutes deposits 3 gram of the metal. What is the equivalent weight? Listen here. What is the 9.65 and it is 10 minutes, that means 60 seconds, 10 into 60. Now I into T, so it is 9.65 into 600, or I can say 965 into 6. It is a coulomb. How many Faraday? I will divide by 96500. So 6 upon 100, that means 0.06 Faraday. 0.06 Faraday. Listen, if 0.06 Faraday is producing you 3 gram, so how much gram will be deposited by 1 Faraday? Listen, 1 Faraday will deposit 3 upon 0.06, है ना, this will be the 100, 3 2s and it will be 50. So 50 will be the answer. What is equivalent weight? If I am talking about equivalent weight weight is of any. It will be the weight that will be deposited by the 1 Faraday mass. It is the Faraday's laws in which we discuss this thing, है ना. 1 Faraday charge will deposit the mass equal to equivalent weight of any metal. For a chemical reaction A plus B gives product, the order is 1 with respect to each A and B, value of X and Y from the given data. Order with respect to is 1, order is given 1, है ना. If you will see if you are taking the 4 time, that means you are multiplying 4, you are okay, please see, this is the A, this is the B concentration, है ना. Okay, let's see. The concentration of B is same and the rate is going to be multiplied by 4. That means you are going to increase the concentration of A by 4 times because order is with respect to it is also 1. So what is the fourth multiple of 0.2? It is 0.8. A and D option wrong. And if you will observe this, you are taking double of this. So, and the rate is going to be multiplied. You are taking double, so it is multiplied by 8. So that means you are taking it 4 times. Na? 4 to the 8. So 4 times. What is the fourth multiple of this? 4 5 is 20. That means 0.2. So 0.2. It is wrong. Na? 0.4, 0.2. So 0.2. Hai na? C will be the right answer in case of this. Now 78th. What is the half-life of radioactive substance if 87.5% of this given amount substance disintegrate in 40 minutes? It is a first order reaction. And how to solve? A to A naught by 2, then A by 4, then A by 8, or I can say it is T50, it is T50, it is T75, it is T87.5, है ना? T87.5. Now it is taking 40 minutes time for this. How many half-life? 1 half-life, 2 half-life, 3 half-life. So 3 half-life equal to 40 minutes. So 1 half-life equal to, 3 half-life equal to 40 minutes. So 1 half-life will be equal to 40 upon 3, 13 minute, 13.33 minutes. I know. Now, an endothermic reaction A plus A gives B have an activation energy 15 kilocalorie and the heat of reaction is 5. It is endothermic reaction. So obviously endothermic reaction. Activation energy 15 है ना, and the heat of reaction is 5 kilocalorie. It is 5 kilocalorie. The activation energy for the backward. So listen, I will have to move from here to here. Listen, it is total 15, it is 5. So what is this? It is 15 minus 5, that means 10. It will be the right answer. The half-life for a reaction of temperature. That means what is the relation between half-life and if you will see the half-life of zero order reaction, it is T half is equal to A naught upon 2K. Half-life of first order reaction, it is 0.693 upon K. You can see that T half is inversely proportional to K, T half is inversely proportional to K. I can say that T half is inversely proportional to K, and I know that on increasing if I will increase temperature, K will increase, and if K will increase, T half will decrease. So on increasing temperature, T half will decrease. T half will decrease 80. Or increasing temperature, T half will decrease. Whatever, you can choose the option according to condition. Question number 81. What is the correct relation between this? We know that mole fraction in the vapor phase according to Raoult's law. Dalton's law we will apply here. Mole fraction in vapor phase. It is Ya is equal to Pa upon P total. He is using the term PS here for this. I think he is using only this term. Now Pa, we know that it is P node A according to Raoult's law into XA upon P total. So there is only one option that is left, D option. In this question they should also mention that what is PS. Okay, but it is understood that in any option he will provide the P total. Na? There is no P total. So obviously he is using PS term for P total. Question number 82. If you will see, pure benzene freezes at this, okay, at a certain place, but small m solution of tetrachloride benzene freezes at this. What is the change? 5.45. You can see 5.45. Please wait. In this question, if you will see, 5.45. What is the change? 5.45 minus 3.55. 0, 14 minus 5, 9. It is 1 point, है ना? So 1.90, we know the formula delta T is equal to IKFM, है ना? Benzene freezes at tetrachloro CCl4 na, tetrachloroethane, it is not methane. Okay, I will be 1, Kf we will have to find, M it is given as 0.375. So what is there? 1.90 upon 0.375. If you see that 5 है ना, हाँ, so it will be 5 times, so obviously this will be the right answer. If you will calculate it, 1 upon 1.90 upon 0.375, it will be 5 times. Direct formula based question actually. The Vanta factor for a dilute aqueous solution of glucose, obviously glucose 1, है ना? Which of the following solutions will have the highest boiling point? Highest boiling point, we know that elevation in boiling point, higher the number of particles, there will be higher the boiling point. Colligative property, second number. 1%, so no matter. Now, glucose is having I factor 1, so we will have to provide the answer according to I factor, Vanta factor. Higher the value of Vanta factor, that will be the right answer. Okay. So here Vanta factor is 2, there is 3 plus 2, 5. Vanta factor is 5. Urea is having only 1. So this will be the right answer. Now, next question, if you will see, CH3 minus is less stable than, that means CH3 minus is more stable as compared to which option? CH3 minus is less stable than, that means CH3 minus is more stable. So you can see that here it is unstable, here it is stable because of minus I effect of NO2, and is less stable than, so it is more stable. So obviously it is CH3 minus is less stable than this because it is stabler than CH3 minus, है ना? All these three options are, है ना, lesser stable than CH3 minus, but is not asking, he is asking that CH3 minus is less stable than which? It is more stable than CH3 minus, so obviously CH3 is less stable than this. Question number 85. Now I am talking about 86. Most acidic compound. H plus removed here, H plus removed here, H plus, okay, H plus, okay. We know that benzoic acid is more stable, more acidic than phenol because it will be having a quality resonance, है ना? It will be having a quality resonance. Minus charge will be on more electronegative atom, but here minus charge will be on carbon. So oxygen will be having minus charge, it will be very great for us. Oxygen is very electronegative atom, if it is having minus charge, so it will be stable. So now option B, C, D. Here you are going to see that NO2, which is showing minus R effect, so it will stabilize the anion. So here minus charge, it will be stabilized by minus R effect, so it will be the most stable anion, so that's why it will be showing the most acidity here. Now 87, the correct order of acidic strength of the following. Here only phenol, paracrisol, it is phenol, paracrisol, okay, metanitrophenol, okay, good, and paranitrophenol. If you see here, if H plus will be removed, so anion will be formed, and this CH3 due to hyperconjugation and due to plus I effect, it will destabilize, so it will be showing the least acidity. So B should be at the end, so only this option is having B at the end, but okay, let's see the option. Then this And now we will see that this is being stabilized, this is being stabilized. That means C and D anion are going to be stabilized, but here minus R is able, minus R as well as minus I, but here only minus I, because at meta position resonance will not work now. Here it is minus R. So that means, my dear students, it will be the most stabilized, most acidic. That is D will be the most, then C, then A, then B. Question number 88. Hydrogen attached to sp3 carbon in cyclopentane can be easily removed as what? Cyclopentadiene. Listen, there is hydrogen. If I am going to remove as a anion, H minus, so there will be a cation. So you can see how many electrons in this? 4 pi electrons. That means anti-aromatic. Suppose I am going to remove it as H plus and there will be a minus charge. So 2 plus 2 plus 2, 6 pi electron aromatic. So I will remove it as H plus. That means proton. Now question number 89. If you will see NO2 plus, it is an electrophile. So obviously out of these two rings, the ring that will be acting as a good nucleophile, it is going to attack on the electrophile, and you can see that it is showing plus R effect. So that means this ring is due to plus R effect of O. It is electron rich. It is a good nucleophile. So it will attack on this electrophile. Its ortho para position can attack. So you can see that the ortho para product on this ring will be the final answer, but ortho will be less because due to the steric hindrance. So para will be the product. If you will see this reaction, this ring, so it will be, there will be a minus R effect. So this ring will be having a positive charge. It cannot act as a good nucleophile, while it will act as a good nucleophile, है ना? Here, here, so minus here and here, फिर minus. So the answer will be that option where you will be getting product here, attached here, electrophile, है ना? You can see this is the right answer. Now next, hydrolysis of optically active 2-bromo, hydrolysis of optically active 2-bromo butane, है ना? Two bromobutane. So you can see this carbon is optically active. It is a chiral carbon, right? So if I am going to allow the hydrolysis, so listen online students, OH, okay, hydrolysis, it can come and attack on any side, है ना? Suppose what I am going to do, I am going to take a removal of this. In the first step, carbocation is going to be formed, C2H5 H as CH3. It is CH3, it is C2H5 and it is H. Br has been removed. So it is the carbocation or intermediate that is going to be formed. Now what is going to happen? This H2 as a nucleophile can attack from the top or it can attack from the bottom. So if in one position you are going to get a dextro, in another position you will be getting a levo. So there will be a DL butane 2 all. Mixture of D and L, not only D or L, because there is a equal probability of attacking. Now it is a trigonal structure, intermediate, right? A primary alkyl halide would prefer, primary alkyl halide online students, a nucleophile can attack easily. In the same attack, in the same step, nucleophile will attack and living group will be removed, departed. So it is SN2. SN1 we know at 3 degree alkyl halide will prefer SN1 and 1 degree will provide SN2. So very straightforward question. PST alcohol, primary, secondary, tertiary, we know Lucas test and now ZnCl2 plus HCl. Okay, so Lucas test, what is the functioning of ZnCl2? To make a good leaving group of OH. Now this question here, listen, that means CH3 is attacking. Suppose what is the possibility of B? Obviously it will be like this. Obviously it will be like this. Obviously it will be like this, so that your CH3 minus will attack here and it will be turned into there, and then after hydrolysis this O minus will be having OH. So it is acetone. B is acetone. And how you can have a ketone? Obviously or by oxidation of 2 degree alcohol, है ना? So 2 degree alcohol and having 3 carbons, CH3 CHOHCH3. Yes, it is a ketone already. No, it is an acid alcohol, but it is a primary alcohol. It will provide you, after oxidation it will provide you acid, not ketone. So obviously, because 1 degree alcohol provide you as acid after the oxidation by a strong oxidizing agent, है ना? K2Cr27, it is a strong oxidizing agent. So A is the right answer. Now if you will see, it is the reduction reaction of phenol, direct reaction. ZNO will be removed and you will be getting a benzene, and then CH3, this X is benzene, and then AlCl4 minus and CH3CO plus electrophile will be formed, electrophilic substitution reaction, and you will be having this. It is known as acetophenone, not diphenyl, not methyl salicylate. It is acetophenone. Benzophenone is benzene ring CO. Benzene ring is this side, benzene ring here this side, and these two both benzene rings are attached by CO. That is benzophenone. Now question number 95. The major organic product of the following reaction. If you will see here, NH2CH3, we know that amine and the reaction of aldehyde and ketone. It is ketone, by the way. I can write NH2 in this way, and there will be a removal of water. Imine are going to be formed in this reaction in the first step. NCH3, okay, imine. And now reduction by LLH4. We know that hydrogen will be added here and another hydrogen will be added here. So you will be getting this NHCH3. Which will be the right answer? How carbon can be there now? There is no carbon is given to you. Okay. So this will be the right answer for question number that was okay. Let's see 96 now. Question number 96. Now we will see the question number 96. Okay. CH3 in methods of preparation of haloalkane, you know that what is this? Then aqueous KOH, it will act as a nucleophile. Alcoholic KOH will act as a base. It will act as a nucleophile. So you will be getting CH3 CH2OH. OH minus will attack here and it will be removed. Now PCC, it is 1 degree alcohol and weak oxidizing agent. It will provide you aldehyde. And now you know OH minus, that means base. Okay. So what is going to be happen? It is aldehyde having alpha hydrogen, so aldol reaction, right? How to predict the product? It is the short trick of aldol. I have told you. Two bond will break and two bond will be formed. Right, Aji? Now you are going to heat it. We know that it is aldol. aldol on heating will H will be removed from here, OH will be removed here. You are going to write this unsaturated aldehyde. This will be the right answer. No, H has been removed, now, so it will be having only one hydrogen. Now, question number 97. When propanoic acid is treated with aqueous sodium bicarbonate, CH3, CH2, COOH. If I am going to take Na sodium bicarbonate, now NaHCO3. So H will be removed, and in place of this O minus Na plus will take place of this, and what is going to form? This H plus and HCO3 minus will form H2CO3 है ना. This H2CO3 will provide you CO2 and H2O. CO2 gas. So CO2 gas is coming from H2CO3. H2CO3 is coming from NaCO3. So from bicarbonate, sodium bicarbonate. This is not the CO2 of this your propanoic acid, है ना. Now question number 98. Okay, let's see. It is Halfman bromamide reaction. So what is C? C is CH3, CH2, CONH2. It is Halfman bromamide reaction, obviously. And yes, if you will see option, so definitely there will be any acid or acid derivative. What I want, if you will see, what I want CH3, CH2, CONH2. I want this, and from which after the reaction with NH2 you can form this. Listen, this is that. If I will react with NH3, you know, it will attack here again, then it will be removed, है ना. So COO, and there will be NH3 plus. Then heating, so obviously deprotonation will take place, and you will be getting this. What is this? It is that, है ना. So this will be the starting material. After this reaction, after reacting with this will be formed, and this after Halfman bromamide reaction, it will provide you CH3CH2 NH2. That is the question number 98. It will be having C answer. Okay, sorry, D answer. CH3CH2 COOH. Now CH3CH2 COOH will form CH3CONH2, CH3CH2 COOH, CH3CH2 CONH2. हाँ, फिर एक CO रिमूव हो जाएगा. Now question number 99. On complete hydrolysis of starch. Obviously we know that how method of preparation of glucose. We see that complete hydrolysis of starch will provide you glucose. Carbohydrate that cannot be hydrolyzed to simpler forms is called monosaccharide. Disaccharide will provide you 2, trisaccharide will provide you 3, and polysaccharide will provide you many, lot of number of more than 10, because 2 to 10 they are known as oligosaccharide, not polysaccharide. So that was all about this. Thank you for watching.